Hello, 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 Algebra 2 students. Today we are going to learn about function notation and how to compose functions. It's a very different from 8.1 and 8.2, so let's just jump in. First, we're going to have these two functions. F of x is negative 4x and g of x is 2x plus 3. When you do addition of functions, we're just going to take the two functions and add them together. But when we do that, the notation looks a little different. It looks like f plus g of x. And this just means that we're going to take f of x and we're going to add g of x to it. So let's look at this. F of x is going to be this function and g of x is going to be this function. So I can just add those two together. So it's going to look like negative 4x, and I'm taking that and I'm adding this is the f of x function, and I'm going to add the 2x plus 4. Just so like if highlighting's your thing. This is the f of x, this is the g of x. And now, because I'm adding it, I don't have to distribute any negative or anything. I can just combine like terms. So I've got a negative 4x and I'm adding 2x. That's going to be a negative 2x. And then there's nothing to add to my 4. So that is addition. I'm adding those two functions together. Subtraction, or the notation looks like this. F minus g of x. That's how you read that, f minus g of x, which just means that I'm going to take my f of x function and subtract my g of x function. This time, it is important that you subtract and you're going to have to distribute the negatives. So our f of x function, again, is 4x, or negative 4x, and we're going to subtract 2x plus 4. Again, in this notation, I'm just taking the f of x function and plugging it in, and taking the g of x function and plugging it in. In this case, it does matter that negative is going to get distributed to both of the second terms. So negative 4x minus 2x minus 4. Now we're combining like terms. I don't need another color. 4x minus 2x is negative 6x, and then a minus 4. I do want you to notice, like, you don't have to write this down if you want to, but if the notation they gave us was g minus f of x, it would be backwards. We would take the g of x function and subtract the f of x function, and that would be different. It would be 2x plus 4, and we would subtract the negative 4x, which would mean that this would become a positive. So we would get 2x plus 4 plus 4x, which would give us a positive 6x plus 4. So when you're doing subtraction, especially because of that negative getting distributed, you got to make sure you're doing the right order. All right, multiplication is going to be super similar. The notation is f times g of x, which means we're taking the f of x function and we're multiplying it by the g of x function. So we're taking negative 4x and we're going to multiply it by 2x plus 4, which means I just have to distribute that negative 4x in. So I'm going to get 4x times 2x is negative 8x squared, and negative 4x times 4 is negative 16x. All right, the division notation looks like f divided by g of x, which means we're just going to take our f of x function, that's the one that was on top, and we're going to divide by our g of x function, that's the one that's on bottom. So this was negative 4x, and we're dividing by the g of x function, which was 2x plus 4. We just did rational, so we know that we can factor that bottom part of the equation. So it's going to be 2 times x plus 2. And I can cancel out these coefficients, so that's negative 2x over x plus 2. All right, moving on. We're going to use power functions to do the same exact thing using notation. All right, a power function looks like y is equal to a times x to the power of b, where a is a real number. So in positive, negative, rational, irrational number, and b is a rational number, meaning it's a whole number, or it is a fraction. We're going to use fractional exponents right now. So I want you to try these ones on your own. We're going to do f plus g of x. We're going to do f minus g of x. And we're going to do f times g of x. And we're going to do f divided by g of x. All right, you try them and then check back with me, or pause it. Pause the video. I'm a video. You can pause it. And check back with me, see if you're getting the same stuff. So first, we're going to take f of x to the power of 1/2, and we're going to add the g, which is negative 9x to the power of 1/2. I can just drop the exponents because I'm adding. It doesn't change anything for x to the 1/2 plus, plus a negative x to the 1/2. These are like terms. I have the same variable, same exponent, power of 1/2. So 4 minus 9 is just going to be negative 5x to the power of 1/2. All right, f minus g of x. Oh, so this is the final answer. Boom. All right. F minus g of x, I'm going to take my f of x power, which is just 4x to the power of 1/2, and I'm going to subtract g of x, which is negative 9x to the power of 1/2. What that negative does, a minus a negative is adding, so we're going to do 4x to the power of 1/2, and we're going to add 9x to the power of 1/2. Again, like terms, same base, same exponent. I can just add the 9 and the 4 and get 13x to the power of 1/2. All right, when we're multiplying, we're going to remember our power rules that we learned, or we learned it in 7.1, but we did it last class in 8.2. We're going to take f of x and we're going to multiply g of x. So we're going to take 4x to the 1/2, and we're going to multiply, this just means we're going to multiply negative 9 times x to the 1/2. Remember, we're taking our f of x function and we're multiplying our g of x function. In this case, we just get to multiply the coefficients. 4 times negative 9 is negative 36. And x to the 1/2 times x to the 1/2, when I have the same base and I'm just multiplying, I get to add exponents. 1/2 plus 1/2. 1/2 plus 1/2 is 2 halves. Negative 36x is 2 over 2. Remember, the denominator stays same. I'm adding the x, or the numerators. 2 over 2 is 1. So I'm going to write this as negative 36x to the power of 1. I don't have to write to the power of 1. All right, f of x divided by g of x means that I'm going to take my f of x function, then negative 4x to the power of 1/2, and I'm going to divide by negative 9 times x to the power of 1/2. It's not a negative, this is a positive 4x. So the x to the 1/2 and the x to the 1/2, I have the same thing on the top and bottom. They cancel out, and I'm just going to be left with 4 over negative 9. And that's my final answer. All right, we're going to do a composition of functions. It's a new symbol. We have addition, subtraction, multiplication, division, and now we have composition. We're going to put one function inside the other function. Remember, say we have f of x is 3x minus 8, and we did f of 4. What we would do is anywhere we see an x in the x or in f of x, we're going to plug in x, right? So we would do that. We would do 3 times 4 minus 8. And so if we have f of 4, that just means we're plugging in the 4 into the f of x function. When we see g of f of x or g of f of 5, that means we're going to put one function inside the other. So it's going to look like g of f of 5. So we're going to first plug in 5 into the f function, and then whatever the value is for that, we're going to plug it into the g function. It's a function inside of a function. So let's just walk through this super slowly. So first we're going to do the most inside part. We're going to do the f of 5. So f of 5 means we're going to take our f function, and wherever we see an x, we're going to plug in 5. So 3 times 5 minus 8. 3 times 5 is 15. We subtract 8 and we get 7. All right, so I know f of 5 is equal to 7. So instead of f of 5, I know it's 7. So now I'm going to do g of 7. I'm going to plug 7 in. I'm substituting in f of 5 is 7. I'm substituting in that 7 and finding g of 7. The g function was 2x squared, so it's equal to 2 times x, or sorry, 7 squared, because wherever I saw an x, I'm going to put in 7. And we follow order of operations. 7 squared is 49. So 2 times 49 is equal to 98. That's my final answer. I'm just going to write it in function notation. G of f of 5, because that was the original thing we plugged into, was equal to 98. All right. I encourage you to try this on your own, see if you get the same thing that I'm getting. We're going to do f of g of 5. So this time, instead of plugging into the f function first, we're going to plug into the g function first, g of 5. So let's do that. G of 5 is equal to 2 times 5 squared. Order of operations says that's going to be 25, and 2 times 25 is 50. So I know g of 5 is equal to 50, and if I'm going to do f of g of 5, I can plug in that 50. So in the f function, that's going to be 3 times 50 minus 8. And I'm using these two functions right here. 3x minus 8, and g of x is 2x squared. So 3 times 50 is 150. I subtract 8, and I get 142. 142. All right, the last one is a little tricky. It says f of 5, so that means if the f of x function, we're going to do f of 5. We're going to put the same function into itself. So the first thing I'm going to find is f of 5. F of 5 is equal to, it was 3x minus 8, so we're doing 3 times 5 minus 8. Simplify that. 15 minus 8 is 7. So I know f of 5 is equal to 7, so I'm going to substitute that in for f of 5. So we're going to do f of 7 this time, and we're going to do 3 times 7 minus 8. 3 times 7 is 21. 21 minus 8 is 13. That's when we're using numbers. Now we're going to move on to doing the same thing with x's. F of g of x. You might see it like this. This means you're going to take the f of, remember, this means we're just taking something and we're plugging it in here. It could be a happy face. We could do f of happy face. And anywhere in the function where I see a x, I'm plugging in a happy face instead of x. But this time it's saying I'm going to put the whole g of x function in wherever I see an x. So in this case, I have f of x is going to be 4 times something to the power of negative 1. That something that I'm plugging in is the whole g of x function. That's the part where it says 5x minus 2. 5x minus 2. So wherever I saw an x in that f of x function, I'm plugging in 5x minus 2. And now I'm just simplifying it. Do I like negative exponents? No. This whole thing, this part right here, is being raised to the power of negative 1. So all of it, I'm going to move to the bottom of the fraction. The 4 stays on top. Everything else goes to the bottom. 5x minus 2 to the power of 1. I don't have to write to the power of 1, so this could just be 4 to the power of 5x minus 2. That is wholly complete. All right, this one is g of f of x. So we plugged the g of x function into the f of x function. Now we're going to go the other way around, and I'm going to say I'm going to take my g of x function and plug in my f of x function. So g of 4x to the power of negative 1, and anywhere in that g function where there's an x, I'm going to plug in 4x to the power of negative 1. So 5 times 4x to the power of negative 1 minus 2. All right, let's simplify. 5 times 4 is 20. X to the power of negative 1 minus 2. I don't like negative exponents. The only thing that's being raised to the power of negative 1 is the x. That's what's going to move to the bottom. So it's 20 over x to the power of 1 minus 2. There we go. Simplified. All right, let's do a couple more like that. Again, I encourage you to pause it and try them on your own and see if you're getting the same things as I am. This means we're taking our f of x function, and anytime we have an x in our f of x function, we're going to plug the whole g of x function in, which really means we're going to find f of, what is the g of x function? It is 3x minus 1. So this one's a doozy. So I'm going to do 3x minus 1 squared plus 3 times 3x minus 1. All right, a common mistake, I'm going to write it in red so you know it's wrong. A common mistake that I see is that you guys just distributing this 2 out, so you get 3x squared minus 1 squared. That's baloney math. Don't do that. What squaring means, when you square something, it means that you're saying x squared is literally x times x. So if you have 3x minus 1 squared, we're going to do 3x minus 1, and we're going to multiply it by 3x minus 1. I can also distribute this 3 out. So 3 times 3 is 9x. 3 times negative 1 is negative 3. When I see this, I have to FOIL. 3 times 3, or 3x times 3x is going to give me 9x squared. 3x times negative 1 is going to give me negative 3x. Negative 1 times 3x is negative 3x. And negative 1 times negative 1 is positive 1. I combine like terms. 3x and 3x, so I get 9x squared minus 6x plus 1. And I'm just going to bring down the plus 9x minus 3. I'm going to look for like terms. I've got a 9x squared, no like terms. I've got a negative 6x and a positive 9x. That's going to give me positive 3x. And a positive 1 and a negative 3 give me negative 2. That is f of g of x. I'm plugging the g of x function into the f of x function. All right, let's continue. We're going to move on to g of f of x. So I'm going to color code it just in case that helps you a little bit more. We're going to do g of, and inside the g function, we're going to plug in the f of x function. So sometimes I write it like this. I write out the whole g function. I'm going to say g of something, and I leave myself a gap, is equal to 3 times something minus 1. G of something is equal to 3 times something minus 1. That something I'm plugging in is the whole f of x function, all of this. So x squared plus 3x is equal to, and then inside here, 3x minus, oh, not 3x minus 1. Ooh, I lied. It's going to be x squared plus 3x. Anywhere I see that x, I'm going to plug in this. So now I'm just simplifying. So 3 times x squared is 3x squared. 3 times 3x is 9x minus 1. There are no like terms to combine, so this is just the answer. All right, this next one is tricky. F of x. So I'm going to do f of x. Inside my f function, I'm going to plug in my f of x function. So that one was, it's f of something is going to be equal to something squared plus 3 times something. And that something I'm going to plug in is x squared plus 3x. X squared plus 3x. It's those two functions I gave you up here. I'm still using these two functions. So x squared plus 3x. So when I simplify this, I just got to make sure I follow order of operations. When I do x squared plus 3x squared, it's not going to be x to the fourth plus 3x squared. It's going to be x squared plus 3x times x squared plus 3x. And then I can distribute this right here. So it's 3x squared plus 9x. I have to FOIL these first two binomials. So that's going to be x to the fourth. X squared times 3x is going to give me 3x cubed. 3x times x squared is going to give me 3x cubed. And 3x plus times 3x is going to give me 9x squared. I have these two terms from the second part. And I'm just combining like terms. I have an x to the fourth. I have an x cubed and an x cubed. That's going to give me 6x cubed. I have a 9x squared and a 3x squared. That gives me 12x squared, and then just a 9x. Nothing to combine there. All right, what happens when we put the g of x function into the g of x function? Again, I encourage you, I hope you're pausing it and trying it on your own. We're going to take the g of x function, and inside of it, we're going to plug in the g of x function. So let's write that out. G of something is going to be equal to the g of x function, let's just put it up here, is 3x minus 1. So g of something is going to be equal to 3 times something minus 1. That something I'm going to plug in is going to be 3x minus 1. All right, so I'm just going to simplify this. It's going to be 3 times 3x is 9x. 3 times negative 1 is negative 3 minus 1. I have these two like terms to combine, so that's 9x minus 4. Okay, we're going to use these two functions, a negative x squared minus 2x and a 4x plus 5. Try those on your own, and we will, I'm going to show you all my work in just a second. So try these 4 problems on your own and then check in with me, or pause it and then try press play to see the answers. All right, I hope you tried those problems. Here's my work. On this first problem, the biggest mistake I'm going to see is this negative not being distributed to make it negative 4x and a minus 10. Yeah. On the second one, you're foiling. Make sure you're watching your negatives. This should be the answer. When we FOIL, make sure you're adding your exponents too. Remember, when we're doing numbers, it's easy. You're just plugging in f of negative 4 first. We know f of negative 4 is 8, so I can plug in negative 8 into the g function and solve from there. On this last one, there's a couple places where mistakes are going to be made. The first is trying to not FOIL. Make sure you're doing 4x plus 5 times 4x plus 5. And once you FOIL that out, make sure this negative also gets distributed. This negative is going to make distribute to every sign and make all of these signs opposite. So these are my answers. Make sure you're checking your work. See if you get the same stuff that I am. That is it. Thank you so much.